Hi, Algebra. Welcome to part 2 of 7.4 Radical Expressions, where we are simplifying radical expressions. Before we get started, I want to acknowledge something and put your mind at ease. These are all brand new concepts, so I don't expect perfection. I don't expect perfect understanding. I just want you to get the idea of how this works so that it's not completely new next time we see it. Yesterday, we looked at simplifying expressions, and we are going to do the same thing today, but we are looking at 9 through 14 and 23 through 26. The reason I wanted to look at 9 through 14 is because in each of these, you've got a denominator under the radical sign. Okay, you've got a denominator that has a radical sign, or an expression with a denominator that has a radical. And that is not allowed. That is not in simplest form. So we've got to get it out, but we have to use the rules of math to do so. So we will be looking at the even problems, and let's get started. So we are looking at number 10 first. Number 10 says the square root of 6 over 7 times the square root of 1/3. Since we are multiplying and they're both under the square root sign, we can multiply what's inside. So let's do that. 6 times 1 is 6 over 7 times 3 is 21. All right, one thing I want you to notice is that this fraction under the radical sign is not in simplest form. So we need to make it in simplest form. Remember, we're trying to simplify everything. So if we were to do that, we could divide both by 3. 6 divided by 3 is 2. 21 divided by 3 is 7. So this is the square root of 2 over 7. The problem is you don't get to have a radical sign in the denominator. And the square root of 2 over 7 is the same thing as the square root of 2 over the square root of 7. This, not allowed. So we have got to get it out. And there's a simple way to get rid of the square root of 7 in the denominator, and that is to multiply by the square root of 7. But again, we've got an expression. We need to keep it in simplest form. So if I want to get rid of that square root of 7, I'm going to do the square root of 7 times the square root of 7, because this is the same thing as 1. So in order to keep this proportionally the same, I can multiply it by this. All right. Then we multiply straight across. The square root of 2 times the square root of 7 is the square root of 14. Over the square root of 7 times the square root of 7 is just 7. So you've got the square root of 14 over the square root of 7. Let's see if we can simplify the square root of 14. Does 14 have a square factor? Well, it's got, 1 doesn't count again, but 2, 7, and 14, they are not. So this is in simplest form. And we use multiplication to get a full number in our denominator. So again, there is a problem. You cannot have a denominator with a radical under the denominator. So we had to multiply to get it out. All right, let's look at number 12. Number 12 is 45 over 4m to the 4th. And that's all under the square root sign. So what I want to do is I want to kind of separate this out a little bit and do the square root of 45 over the square root of 4m to the 4th. Okay. The nice thing that I notice is 4 is a square number, and m to the 4th is also a square number. So what we can simplify this out because it is a square term under the radical sign. So the square root of 4 is 2. And again, when you have an exponent and you're finding the square root of that exponent, you divide by 2. So the 4 divided by 2 is 2. So the square root of m to the 4th is m squared. So our radical sign is done. We need to see, though, can I factor out a square factor from 45? And the answer is yes, because 45 is 9 times 5. Well, 9 is a square number. So the square root of 9 is 3, and we've got the square root of 5 left. So the square root of 45 over 4m to the 4th power is 3 times 5, 3 times the square root of 5 over 2m squared. That is in simplest form. All right, let's look at 14. 14 is 3 over 2 minus the square root of 3. All right, here is the issue with this one. On number 10, we ended up with just one term under the square root sign, just one term in the denominator. This also is one term under the denominator, but this is 2 terms. And when you have 2 terms, we're going to get to the y's later, but I'm just going to tell you how to get rid of it. If you have 2 terms, you're going to write these 2 and the square root of 3, but you got to change the minus sign to a positive sign. It is not going to make sense to you right now because we have not multiplied binomials yet, but this is called a binomial because it's 2 terms. And when you multiply a binomial times a binomial, there's a process for that we're going to get to very soon. But I just want to let you know, to get this out, this is how you do it. You're going to multiply, instead of 2 minus the square root of 3, 2 plus the square root of 3. But we got to do it on the top and the bottom. Okay. All right, so now we're going to multiply the top, and again, we got to distribute this 3 because we've got 2 terms. So 3 times 2 is 6, plus 3 times the square root of 3 is exactly what I just said. 3 times the square root of 3 over. All right, this, we'll get to the y's later, but because of how we've got this written, we can multiply 2 times 2, which is 4, and then negative square root of 3 times positive square root of 3 is minus, and the square root of 3 times the square root of 3 is 3. So simplifying further, this is 6 plus 3 times the square root of 3 over 1, which is 6 plus 3 times the square root of 3. All right, again, you're not going to understand the y's. We will get to that later, but you're going to multiply by, you're going to change the sign in the middle, and that will, if we do that, then we can multiply the first term and the second term and just write it. It's a special multiplication process that we'll go over later. Again, 14, I don't expect perfect understanding, but let's go on. All right, number 23. Maybe this will make sense. And 24, 25, 26. All right, I'm going to do 24. And I don't know if you remember, in my room, it said something, I'm going kind of back. In my room, there was a thing that said, plan is E plus L times A plus N. And then there was all this stuff, and it said, your plan has been foiled. And basically, this is a binomial and this is a binomial. And there's a rule to multiplying a binomial times a binomial. So let's look at 24. This might, I don't know if it'll explain 14. We may need to just put 14 to the side and not look at it and not think about it again. All right, 24 is 2 minus the square root of 6 squared, okay? That is the same thing as 2 minus the square root of 6 times 2 minus the square root of 6. All right, when we are multiplying, this is a binomial times a binomial. You have to multiply all the parts together. In this one, we multiplied the first and second. That is really not allowed. It's only allowed in this case because we've got the same terms but different signs in the middle. But in this case, we are going to do the FOIL method, F-O-I-L, FOIL. So we have, this is a term, this is a term, this is a term, and this is a term. So F stands for the first terms. So the first term is 2. In this binomial, the first term is 2. So we're going to do 2 times 2, which is 4. O stands for the outer terms. 2 is an outer term, and negative square root of 6. So 2 times the negative square root of 6, we're going to do 2 times the negative square root of 6 is negative 2 times the square root of 6. Okay? The I is the inner. We've got the negative square root of 6 times 2. So this is the same thing as 2 times the negative square root of 6. And the 2 times the negative square root of 6 is negative 2 times the square root of 6. And L stands for last. It is the last terms are negative square root of 6, negative square root of 6. So we've got the negative square root of 6 times the negative square root of 6. Well, a negative times negative is positive, and the square root of 6 times the square root of 6 is just 6. So if I were to put this all together, then this would be 4. I can combine these. Negative 2 times the square root of 6 plus negative 2 times the square root of 6 is negative 4 times the square root of 6 plus 6. Well, I can combine 4 plus 6. 4 plus 6 is 10 minus 4 times the square root of 6. Whew, so there's your answer on 24. Again, we do first, inner, outer, last. So let's look at 26. And maybe you can try 23 and 25. I think those will be a super challenge, and I'll be very impressed if you are able to do that. All right, so 26 is the square root of 6 plus 4 times the square root of 5 times 4 times the square root of 3 minus the square root of 10. All right, again, we're going to use FOIL, first, outer, inner, last. The first terms, square root of 6 times 4 times the square root of 3. So we've got the square root of 6 times 4 times the square root of 3. Well, this is the same thing as 1 times the square root of 6. So let's multiply our, I lost the name of it. Let's multiply these first, which would be 4. And then the square root of 6 times the square root of 3 would be the square root of 18. And this can be simplified, but we're going to do that at the end. Maybe, we'll see. Okay, outer. The outer terms are the square root of 6 and negative square root of 10. So it's the square root of 6 times negative square root of 10. Well, this is positive, this is negative, so it's a negative. And then 6 times 10 is 60. So the square root of 6 times the square root of 10 is the square root of 60. All right, inner is 4 times the square root of 5 times 4 times the square root of 3. So we're going to do 4 times the square root of 5 times 4 times the square root of 3. I'm going to put this over here because it's not going to match that. 4 times the square root of 5 times 4 times the square root of 3. 4 times 4 is 16. And they're both positive, so it's plus. Square root of 5 times square root of 3 is square root of 15. All right, last is 4 times the square root of 5 times negative square root of 10. 4 times the square root of 5 times negative square root of 10. All right, this is the same thing as 1 times the square root of 10. So 4 times 1, coefficient, that's the word. 4 times negative 1 is negative 4 times the square root. 5 times 10 is 50. All right, this is a mess. Let's see if we can clean it up. I'm going to rewrite this, but I'm going to simplify as I go. So 4 times the square root of 18. Does 18 have a square factor? And the answer is yes. It'd be 9 times 2. The square root of 9 is 3, so I'm going to multiply this times 3. So 4 times 3 is 12 times the square root. 2 is left of 2. And then we got this minus. Let's simplify that. Any square factors of 60? 4 is 9, no. 16, no. Okay, so 4 times 15. All right, the square root of 4 is 2. So it's minus 2 times the square root of 15. All right, we said 15 does not, so this is in simplest form, plus 16 times the square root of 15. All right, last one, minus 4 times the square root of 50. Does 50 have a square factor? Well, the answer is yes, and it is 25 times 2. The square root of 25 is 5, so I'm going to multiply that times 5. So this is going to be minus 20 times the square root of 2. Okay, now we're going to combine what we can combine. I see 12 times the square root of 2 minus 20 times the square root of 2. Well, I've got 12 groups minus 20 groups, and that would be negative 8 times the square root of 2. And then I've got negative 2 times the square root of 15 plus 16 times the square root of 15. Well, that simplifies to positive 14 times the square root of 15. So that is as simple as it gets. Again, 23 and 25 are, they are definitely challenge problems. I'd like you to try them. You may surprise yourself. Again, today's lesson, I'm not expecting perfect understanding. I'm just expecting you to kind of get a feel for how we are working with these radical expressions. If you have any questions, don't forget that you can call or text me or FaceTime me. I can help you through any problems that you need help with. That's from 1 to 3 today and every day during the week. I hope you have a great day. We'll talk to you soon. Bye.